¿Qué hora es? Es que es muy exquisito, tío, lo de la capturadora. Ya cuando conecte más. Vale, ahora sí. Sí, cuando queráis. Sí.
Okay, I will just 2 minutes.
Personaje, sí.
Como tengo hecho unas fotos por ahí.
Te las pasas, Pablo, no tengo ganas de.
Okay, let's start. We are starting sooner than usual today, and we will. Okay, the agenda it's gonna be 1 hour talk till 7, more or less, a little bit more probably, and then we will have some networking time, as usual in the kitchen with pizzas, drinks, right? So thanks to Ernie as usual. Right? So just give me 2 minutes for introducing you to the group. It will go super fast. Who is the first time that comes to the meetup? Okay, very good. So I created that group I will say almost 4 years ago. So even it's .NET, it was created from when .NET Core started, because I had I like .NET. What I don't like is that it was not open source. It wasn't cross-platform, and that was quite a painful experience for me, right? So that frustration, right, started the group. Actually, the good things started with frustration, usually. So these are the topics that we like to talk about in that group. We can have more probably, but it's not about .NET or .NET Core, right? I mean, this is the starting point of the group. Obviously, .NET Core, the platform, it's really cool. We like it, but we like other stuff as well. So this is more or less the things that we are that we really love, right? We have all this DDD, CQRS, of course, functional programming. It's something that we really love, like and F#, of course, and then all the CI/CD, DevOps, Kubernetes, all the continuous delivery. This is something that we really like to talk about in the group as well. So if you feel that you have something to say in these topics, right? So just really come to me, come to the group, right? And you are free to talk in the group. We will have meetups that not previous public speaking is required, right? So we will have meetups more professional, I will say, and more amateur, right? So we call it community edition, as Microsoft says, right? So these the community edition meetups are for non-professional speakers. So the idea is to have some of them, but maybe every 2 months or something like that. And then sponsors. I see a lot of people here that I know from companies that they are helping me, right? It's not about, companies wants to help, but it's not about to help for doing marketing and hiring only. I can understand that part, right? But it's helping because we want to share, we want to learn together, right? So this is the idea. But sponsors are wanted as well. So thanks to Ernie for hosting us. This is really nice because they are providing us that space, and they are not really doing or saying nothing and we have JetBrains as well. We have other sponsors. We have JetBrains that they are giving away licenses. We will have some of them today. So for people, questions are good for getting this kind of prizes, Okay, so yeah, that's all. Let's start. Today it's a really special meetup for me and for a lot of people because we have a .NET legend here that it's called Mark Seeman. So probably most of you are here because you already know him, right? So yeah, let's give him a big applause.
Let's see if that works. Me toca, ¿no?
Ah, sí, sí. Yeah. Bueno, llegas tarde, pero... Bueno, me plata al final. ¿Te quedas al final?
Well, thanks for coming, everyone. So as we heard, my name is Mark Seeman. You know that already. You may also have heard that I wrote a book, and there's a second edition out of it. Dependency injection in .NET. So I'm just gonna be very brief with all the commercial stuff here. But as you may also have noticed, you can actually get it for 50% off. And if you want to do me a favor and actually walk around with this T-shirt, I have one more. So if you would like one, I'll be happy to give it away. It's completely brand new, but it's this size. It's just the size that I have. But we can do that, and I will also be happy to give away the book that I brought here. So this is also a brand new printing of the second edition. So we'll figure out how to do the giveaways. Maybe something with the person who asks the most interesting question, or something like that. I haven't really decided yet. So we'll figure that out as we go along. All right, enough about all the promotion. So. The talk, as you can tell, is called Async Injection, and we'll get into why that is. And since I believe that I have a little bit of time, I may be more than an hour on doing this, but we'll see. I'll keep an eye on the time. So what I'm going to try to do here is I'm going to try to answer some frequently asked questions, and actually more than one. But the talk falls into 3 parts. So the first part of the talk, I'm going to talk about one specifically frequently asked question, and it'll be here in a moment. It's a little bit dark. My slides here are a little bit dark. I hope you can still see, but otherwise we could think about maybe at least doing something with the lights. Thank you. All right. So in the first part of the talk, I'm going to talk about one frequently asked question and why it makes sense to ask that question. But once that first part of the talk is drawing to an end, look at a lot of code for the next hour, but we're going to need to establish, okay, so what's the scenario? So whenever I give a talk about programming, if I can get away with it at all, I always use the same scenario. So I keep coming back to this idea of you can imagine you have to implement an online restaurant reservation system. So you know these things. You want to book a table on a restaurant, so there's a form, and you fill in the form with some details. And oh, by the way, that's my real email address. All the spammers already have it, so now you have it as well. But I'm not going to answer the spammers. But if you write me, I will probably, answer you, unless you end up in my spam filter. But then it's not my fault. So what's going to happen here when you press the submit button is that the application is going to create a little JSON document with just that data, so just the date and the name and the email and the quantity, and just package it up in JSON, do an HTTP post to some web server somewhere. We could call it a REST service if you want to. And then what we're going to look at is the server-side code that's just going to handle that incoming JSON document and make business decisions. So since we already heard that this user group is also interested in doing domain-driven design, we can start with the domain model. So instead of just starting at looking at how we deal with the post method there, the JSON document, let's start with the business decision. So I'm going to model the business decision like this. So we have the incoming reservation object. That's just a data transfer object. That's just the representation of that JSON document. So the name, the email address, the date, and the quantity. And then I'm going to return a nullable int. And there's various issues with this sort of design, but I'm just going to keep it for now because it's realistic. This is what lots of people would tend to do. So I'm just going to keep the design realistic. So what's the int? Well, the integer is a reservation ID, and it might also be null because you can see it's a nullable int. I think we have one chair over here, at least, and maybe one over there in the back. Two, actually, over there in the back. And welcome, by the way. Yes, and mine, I'm not going to use it anyway, so yeah, no, I need it. Go ahead. All right, so, so a nullable int. If you get an integer, that's a reservation ID, that means you have a reservation. If you do not get an integer, that means you have null, that means you have no reservation ID, that means you don't have a reservation. That's the way we communicate our decision to the caller of this method. I am going to fill it out with code in just a moment, but I just wanted to take 1 minute to talk about the signature of the code there, to talk about what's the contract. So if we're doing dependency injection, what we could do is we could inject all the dependencies we need in order to make a decision. So we could have injected a repository. That's what people usually call it, even though everyone knows that it's really a database. Okay. So you may wonder, where does that this is just a read-only property. Where does it come from? Well, it was injected via constructor injection, but constructor injection takes up too much space on the slide, so that's why I decided not to have it there. Because it's 2019, and I expect that people know how a constructor injection looks. And if they don't, and it's 50% off. Anyways, now we have a repository. We can make a query against the repository. We can say, okay, so let's take the reservation date, get all the reservations that are already in the repository for that date. That gives us some sort of collection on an array of reservations. And just to keep the code as simple as possible, I'm just going to do a sum over all the quantities. So this is one of those restaurants that only have one long table, and you all have to sit together. So it's a very modern type of restaurant there. We could also make the logic a little bit more complicated, but yeah, you get the point. So now we have an integer reserved seats. That's the number of already reserved seats. And now, if we also know the capacity of the restaurant, we can now make a business decision. So pretty straightforward. And there's no async and await at the moment, by the way. We'll get to that later on. So we decide maybe to return null if we figure out that we don't have enough remaining capacity, or we may set is accepted to true. I don't know why that's necessary, but code tends to look like that. And then we'll call repository create with the reservation down here. And the intent of that is that it creates or adds the reservation to the database, or to the repository, sorry, and it returns an int. So the int is the reservation ID, and that int just gets implicitly converted into a nullable int. That's the compiler that does that for us. So that's basically it. So you'll notice that at the moment there's no async and await going on here at all. There's no asynchrony. But this is a pretty straightforward dependency injection example. We'll get to the asynchrony in a moment. If we want to model our domain, we might say, well, okay, so where does this try accept method actually live? Well, there's this object here, but we could model that as an interface, and we could call it the maitre d'. Now, a lot of lingo in the restaurant world is based on French, and the maitre d' is basically just a French word meaning the head waiter. So the head waiter is the role in a restaurant that typically makes the decision about who can get a table or who can't get a table. So that makes sense to call it the maitre d', and I also just enjoy so much that I can actually use Unicode in C#. So it's great for demo code, but it's really a bother if you have to type it. So you may not want to do that in your actual code. But anyways, so we have this interface. It could have other methods as well, but in this case we just have this one. Okay, so that's our domain model, if we will. Okay, so how do we handle the incoming JSON document? Well, at the boundary of the system, we have a controller, and on the controller, there's a post method, and it returns something called an action result. And again, if you're not doing a lot of web programming in your day-to-day job, then don't worry about this. That's actually not so important. Basically, the idea is that when that JSON document arrives, it gets, this reservation object gets populated. We do some stuff. We return something that represents an HTTP response, and then that's it. Okay, so if we're doing dependency injection, we could now inject one of those maitre d objects into the controller, and then we could just delegate the decision, responsibility to that. So just pass things on. In a real application, we might do some input validation and so on, but I'm just skipping that because it's not really important for the talk. So once we have the ID back, we can look at it and we can say, well, okay, so if that's null, I'm going to return some sort of error saying table unavailable, and otherwise I'm going to return OK. So this internal server error, this is just a little helper method. You could imagine maybe it's a helper method that sits on a base class, something like that, and it just returns one of those action results. So this is a particular action result that represents a 500 internal server error. And I always get into discussions of whether this is the RESTful way of doing this, and it doesn't have to be. There's other options here, so let's just not, worry about that, because that's, again, not the important part here. And we have this error message if there's an error. Otherwise, we would just return 200 OK, everything is good. But notice that if we do that, I want to return the integer, the value of that reservation ID. So that's the contract that this system has with any HTTP clients that talks to it, that if we accept the reservation, we should return the reservation ID in the response body when we send the response back. And we can't break that contract. That would be a break and change, and we're not going to do that. So okay, so far so good. Now, if we're following this, there's this thing called the dependency inversion principle that says it's the client that gets to decide what APIs and what polymorphic dependencies look like. The maitre d or the try except method that we looked at before, it used a repository. So basically, just by implementing that decision logic, I knew that I needed to have a read reservations and a create method. So the reason why the repository ends up looking like this is because that's what the client needs. That's what the try except method actually needs in order to make its decisions. So that's the dependency inversion principle, that the client gets to decide what the abstraction looks like, and not the other way around. But now we look at this and we say, well, we very sneakily called it a repository, but everyone knows that it's really a database, okay? And it's usually a relational database. Like 9 out of 10 times it's a relational database. It could also be a document data database or something else, but some sort of out-of-process persistent store, at least. So the next thing, someone comes by and says, well, this is an out-of-process system, probably a database. We should really, talk to this in an asynchronous fashion, because that would be more efficient. And I would say, okay, fair enough. That sounds reasonable. How do we do that? Well, we just need to change the return types. So instead of returning, normal types, if you will, we now have to return tasks. Okay, fair enough. Or is it? Now the problem here is that this is a leaky abstraction. Now, the definition of a leaky abstraction is that in implementation detail leaks through into the abstraction. We had a fine abstraction before. If I go back, this is what try except needs. We'll go back to the try except method in a moment. This is what it needs. It doesn't need these methods to be asynchronous at all. It doesn't care. But now we are changing the signature of these things in order to support an implementation detail. That is the definition of a leaky abstraction. And then you might say, well, okay, but who are we really kidding here? Everyone knows that even though we call it a repository, it's a database, okay? So is it a big deal? And I said, okay, maybe not. Let's see what happens. It may or may not be a big deal. Okay, so we'll keep it like that and we'll see what happens then. So we'll go back to the try except method here, because it doesn't compile until you put in those async and await keywords. But that's almost all you have to do. Well, there's one more thing. You also have to change the return type to a task. But that's it. Now it compiles. So it wasn't too bad. Well, it doesn't actually compile because we changed the signature of try except, and that means now the interface, we have to go and change that as well. Now, this starts to bother me a little bit because the idea with this interface was that this was a model of our domain logic. This is our business decision logic. Why does it have to be asynchronous? That's really, really odd. Yeah, I can't even express in words, how strange I think this is. It's just a decision. Why does it have to be asynchronous? That doesn't make any sense. But let's just move on and see what happens. So we'll now have to go into the post method and also, use await and change the signature of the post method. And then, modern web frameworks know how to do asynchronous programming, and so it doesn't matter whether we return an action result or a task of an action result. At this point, everything is good. It compiles and it works and it does what it's supposed to do. So the first question you could say is, was it that so bad? And I would probably say, maybe not. It's okay. I mean, it's pretty mechanical. It's not hard once you get the hang of it. You just use the async and await keywords, and you exchange all the method return types to task of whatever it was before. So that's pretty much it. So it's not hard to do. So from a maintainability viewpoint, it may not be that bad. And what I've shown you so far is, by the way, also the case with dependency injection. Once you go dependency injection, you have to sort of go all the way because otherwise it doesn't really make any sense. Yeah, there's no other way to do that. That's just too bad. You have to live with those leaky abstractions if you want to do asynchronous programming. Oh, really? I love when people come and say this to me. Things like that. There's no other way. Oh wow! This is what we in scientific jargon call a falsifiable claim, and the only thing I need to do to disprove it is to come up with one counterexample. That is the easiest way to shoot down someone else. Not that that's really but still, this is just sometimes an intellectual, fun thing to do, or maybe not. So I'm actually not after trying to shoot down someone. I think the approach that I showed you so far is perfectly fine, and I would choose to just add those async and await keywords and just live with the leaky abstraction in many of scenarios. So I'm not against that at all. But I think it's always good to know that there are other ways, that alternatives exist, because that's what actually makes you a decision maker. If you only know one way of doing a thing, making decisions, you just do what it is that you know how to do. If you can do a thing in more than one way, now you can make a decision. So that's sort of like the route towards becoming, a senior developer or an architect or whatever else you'd like to be. So the point here is, I'm not trying to sell you on what comes next. I'm just going to show you there is another way. And then you get to decide. And I sometimes decide that other way, and sometimes just go with the async and await. Depends on lots of circumstances, and I'll be happy to talk about that afterwards. Right, so this was part one of the talk. So now we get to part two of the talk. So we sort of put this aside for a moment, and then we're going to look at this question instead. How do I get the value out of my monad? And at this point, if you go, what's a monad? Don't worry, I'll teach you. It's easy. And it is not that hard. But basically, the answer here is you don't. It turns out that asking that question actually doesn't make a lot of sense. But we need to understand, first of all, what a monad is and why some people ask that question. And once we've figured all of that out, we can come back and figure out what's the alternative way to do asynchronous programming and dependency injection. So I'm not assuming you know what a monad is. It's okay. It's a concept from functional programming. It's actually a concept from something called category theory originally. I think it came up first in something called differential topology. Yeah, I have no idea what that is. Anyways, that's what people typically tell you when they start talking about monads. It's tell you all those scary things with mathematics and so on. Just forget about that. It's not that hard. It's fairly simple. We need one more scary sounding word, because a monad is a functor you can flatten. And now you go, okay, so what's a functor? Okay. So it seems like we're on our way down a rabbit hole where we're never going to get out again. But no, trust me, that's what we need to figure out. Okay, a functor, and then once you know what a functor is, I can tell you what a monad is, and that's it. And it's pretty straightforward. It's actually not hard at all. Okay, so a functor is a container. It's a data container. So it's not a Docker container. Okay, so container is one of those words that means lots of things. So also not a dependency injection container, actually, not a shipping container either. In this case, when we're talking about containers, we're just talking about containers of data. And true to normal computer science and software development tradition, I'm going to represent that with a rectangle, because that's a container. You can imagine that there's things inside the rectangle. Okay. So you could have lots of data structures that contains data, and you'd say, well, does it, if I have a data structure that contains data, is that a functor? It needs a little bit more. It needs to support what we call a structure-preserving map. I'll give you examples, don't worry. But basically the idea is that we should be able to transform or project all the data inside the container and produce a new container with all the transformed values inside of it, and get a new container out of that transformation. So that sounds abstract. So let's have an example. So the first example is one you know already, and that's just a collection. So here I have a collection of numbers, and you'll notice that this particular collection of numbers is just fairly arbitrary. There's no order. You might think, if you don't look closely, that it's just in ascending order, but actually it isn't, because 7 is actually higher than 1, which is actually higher than greater than 0, but then 42 is greater than 0 as well. So there's no order. This is just a completely arbitrary collection of some integers. And a projection that we might want to do is we could say, well, for example, we could just add 1 to all of the numbers, and now we get a new collection with some new numbers. And so these sorts of collections have values inside of them, and they don't have to be numbers. They might be strings, so we could transform the numbers into strings. So at this point, when we do that, now we start out with a collection of numbers, and now we have a collection of strings. So this sort of implies that if we're looking at a statically typed language, these containers are generics. So this is something, this is actually IEnumerable of int, and this turns into IEnumerable of string. This is just one functor example, okay? One more thing we can do. We could, for example, also project all the numbers into Boolean values, saying, well, are they even or odd? And notice one thing that happens down here is there's actually only 2 distinct values here. There's only false and true, but still we go false, 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 true, true, false. And we do that because we preserve the structure of the input container. So that's what we mean by a structure-preserving map. Exactly what a structure means is different from functor to functor. And so far we've only looked at what we could call the collection functor. But the structure of that one means that the count of elements remains the same. All of these things have 6 elements inside of them. Yeah, 6. And the order of all the output collections are determined by the order of the input collection. So this is not some random order. There's a reason why it's false, 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 true, true, false, and not some other order around. It's because it's determined by the input. We'll also notice that the output of making one of those projections is itself a container. So that means we can use it to as an input for another step. That means these things compose. That's a very, very interesting thing when we're talking about software development, because what we often struggle with is to figure out how to decompose things actually. And it's really hard to decompose things if you can't compose them again afterwards. So, figuring out how things compose is a really, really important key to figuring out how to decompose things. So that's pretty nice. All right, so what would that look like in C#? So here I have is something that is a simulation of a C# interactive session. So just because the syntax is the simplest I could come up with, here's an array, but this could also have been a list of int or collection of int or whatever else, but now this is just an array of ints. So in order to do that projection, you probably used link already. You can go select, and then inside the lambda expression there you go I plus 1. That's adding 1 to each of the numbers, and then you can compose them. So you can go dot select again, and then you can turn them all into strings, and now you get an array of strings. So you know that already. Link has been around in C# for more than 10 years. Even though I have met programmers who still think this is sort of magic, but it's been around. I suppose most people have seen this for now. So that's one example of a functor. All sorts of collections, arrays, list of t, just any enumerable of t is basically just that single idea of a functor called the collection functor. The list functor is what it's usually called. And I told you that if monad is a functor you can flatten, and it turns out that this is also a monad. We'll get back to why that is in a moment. And then we look at the frequently asked question that I'm trying to address here is, how do I get the value out of my monad? So if I try to translate this into this specific example, we could say, well, how do I get the value out of my array? And then you say, well, why would anyone ask that question? That obviously makes no sense. And true, it doesn't. At least if you want to, ask a question like that, you have to say, how do I get the first value out of my array, or how do I get the last value out of my array? And every time you ask that, I'm always going to ask you, yeah, what are you going to do if it's empty? How do you get the value out of an empty array? But people know that arrays and lists and so on behave like that, so they don't ask that question. And I think one of the reasons why people then later on ask the question, how do I get the value out of my monad, is because no one tells you that this is a monad. It's funny, and we'll get back to this. Select is based on the idea of a functor. And it was designed by Eric Meyer, who knows his way around functional programming very much. But the documentation of link language integrated query doesn't tell you that this is a functor. It doesn't tell you that this is a monad. And why they don't tell you that, I'm actually haven't really figured that out. And in some way, in some sense, it's a little bit annoying, and in some sense, it's great because then I get to tell you instead. And I love doing that. Anyways, I think that the reason why people often struggle with this idea of getting the value out of the monad is because when they finally encounter the idea of a functor and a monad, it's often in another context. And we could call one of those contexts a unit container. That's just my made-up, terminology there, a unit container. And here's some examples of it. And you probably know one of the unit containers that's been around for the longest is lazy of t. This has basically been around as long as there's been generics and lambda expressions in .NET. So you'll already notice that this is a container. It's a generically typed container of values of the type t. So is that a functor? Well, it doesn't come with a structure preserving map, out of the box. And I don't know why, but we can make one. And it's basically a one-liner, so we can create a select method, and we can make it an extension method on lazy of t, and you'll notice it returns a lazy of t result. So this should be a structure preserving map, if we can make this work, that maps from t to t result. And what we need to do that, in order to support that, is we need a function that can just map t to t result. And then the implementation is a one-liner. And you can go back and play around with this if you need to do this. But what you can do with an extension method like this is the following. So you could say, okay, so let's define a lazy of int. And you'll notice that it has, a blocking call here. So it's going to sleep for 10 seconds. But because it's a lazy computation, this entire statement completes immediately, as you'd expect it to. Now, what we could do is we have a lazy of int. Let's see if we can turn it into a lazy of string with that new select extension method down there. And that turns out also to complete immediately. So even though we still have this potential thread blocker there, it's still not active. If I try to force evaluation by going y.value, then it's going to block for 10 seconds. And if I try to force evaluation again, it's going to return immediately. In other words, y, this variable here, behaves exactly what we would expect from a lazily evaluated expression. And that means that's the structure of what it means to be a lazily evaluated computation. And select preserves the structure. It's a really fancy way of saying it just does what you'd expect it to do. Okay, structure preserving map means it behaves intuitively. It doesn't mess with your brain. That's basically what it means. So that's nice. I wonder why it's not there in the framework actually. Yeah, but it's a one-liner. It's super easy to add. So what about other containers? We have another type of unit container, something that is guaranteed to return or to contain one value of a thing, and that is task of t. So we could basically do the same thing with task of t. And you notice the implementation is a little bit different, but apart from that, it's basically the same concept. And we can write the same sort of code. We could start a task that will, asynchronously block for 10 seconds, and that completes immediately. That's a task of int. Can we turn it into a task of string by projecting it with the select method that we just added? Yes. That also completes immediately. Now this thing is probably running in the background, but this doesn't take many nanoseconds. So if we try to await the variable y there, that's probably going to block for most of those 10 seconds because this happens pretty fast. And then if we try to await it again, we just get the immediate result back because just like lazy of t, task of t memoizes the result. So the first, once it computed it once, you don't have to compute it a second time. So again, this just behaves the way you'd expect it to, and that means that select method is a structure preserving map. It just preserves the, what you'd expect from a task. So that's a functor as well. So you'll notice that I've written, a couple of times now, y.select and so on. I could also have written it like this. Lots of people don't like this. This is called this is called query syntax. And lots of people seem to dislike this and think it's only something you can use when you're using something against entity framework or something like that. But you can use it with anything that supports the select method. So basically, if you have the select method, this syntax now becomes available to you. So you normally see it in the context where x is some sort of I enumerable or maybe an I queryable. So if x is an I enumerable of int, then y is inferred to be an I enumerable of string, and the compiler can actually figure all of that out. But the funny thing is, if we change x, if we just change the type of x and nothing else here into lazy of int, then y is inferred to be a lazy of string. Now this syntax just becomes possible just because I added the select method. And the same thing goes for task. If I add that extension method, this syntax becomes possible. If I didn't have that extension method, this wouldn't compile. With the extension method, this now compiles. So we have a language feature that is based on, it's not that you have to implement an interface, you just have to provide the appropriate methods with the appropriate behavior, and then the compiler lights up. So we'll get back to the monad. So that's the idea of a functor. It's not an interface you go and implement. It is a more higher level abstraction that is only sort of present in the language in the sense in the form of a language feature, a compiler feature that works if you make sure that the shape of your code is in a certain way. So it's a very abstract idea. It's a container of data that supports a structure preserving map. So that's actually the hardest part. Getting to what a monad is easy because it builds on this. If you understand what this is, then a monad is pretty straightforward. It's a functor you can flatten, and the only thing you now go and say, well, okay, what does it mean flattening? When is a functor not flat? So we go back to the collection functor and have a look at that. So in .NET strings have an instance method called split, and you probably used this many times. So if I have this string, this is a single string foo, comma, bar, and I split it on the comma, and now I have an array of 2 strings, foo and bar. All right, so that's pretty straightforward. Now what if I have a collection of comma separated strings? So here I have an array of 2 strings, and each of them are comma separated. And since this is a collection, I can do a structure preserving map over it. I can call the select method. And then what I'm going to do is for each of the strings, I'm going to split them on a comma. Now what's that going to do? Well, it's going to give you a nested array, because each of those strings will produce a new array. Split produces an array. So you have, the outer array contains 2 other arrays, and then the first element of the outer array is another array containing the strings foo and bar, and so on. Now sometimes this is what you want, but sometimes you don't want that nesting, you just want to flatten the things. So in order to support that flattening behavior, there's another method. Instead of it's calling select, it's called select many. And I haven't asked anyone why it's called select many, but my theory is that we are doing a select just like up here, and for each of the strings S, we're selecting many values because split produces many values. So that's the reason, I think that's the reason why it's called select many. It sort of makes sense. What that one does is it flattens as it goes. So now you just get a nice flattened array. So we have a functor. This is the collection functor. We have a nested functor, an array and arrays, but now we could flatten it. If we can write a select many method that does that flattens, nested functors, then that's a monad. This is basically the idea what a monad is. It's a functor you can flatten. And you often run into this situation where functors become nested. Let's have a look at an example where we say, okay, so how, we've seen arrays can get nested. What about tasks? So imagine that you have, some sort of helper method here that produces a value, and it's a task. So this is a task of int. Now you have another one as well. So you have 2 tasks of ints, and you want to add them together. And you might say, well, I'd like to see if I can do it with this new select method that we had before. So you might try to write something like this, where you go select, but then you have to write an asynchronous lambda expression inside of the select, because otherwise you can't get at the other value there. And you notice that the output there, the type of z is a task of an int. It's nested. How do you get the value out of it, by the way? Well, you can actually go await z. When I wrote this example, I was yeah, it works. So that's okay, I suppose, but I don't know if you imagine that if you have 6 of those and you have a task of an int, and then you go, and wait. I think that's not really pretty. So that's not what we want. So what if we could have a select many method instead of just a select method? It turns out you can write one of those. Again, it's a little extension method. It's basically a 1-liner or maybe a 2-liner. And I'm not going to show you. We can, maybe we can look at it later on, but I don't have a slide for that. But if you do select many, it flattens as it goes, just like it did with the lists before. And now z is just a normal task of int, and that means you can just await it once. It gets even better actually, because if you have the appropriate select many methods, you could rewrite it in query syntax. And now all the async and await keywords disappear apart from the last one down here. Now the reason why this works, when you have multiple from in the same query syntax thing, this is only possible if you have the select many method. So this syntax only lights up if you have a monad. The task of T is a monad. And the collection is a monad as well. So there's definitely a subset of monads that are guaranteed to contain a single value. So lazy of string, we just saw that. How do you get the string out of lazy of string? Well, you force evaluation by calling dot value. How do you get the value out of a task of something? Well, you can await it. And this is not even only something you see in C#. You run into the same sort of issue or the same sort of concept in F#, where it's just async, and you can get the value out of it by calling async run synchronously. And even Haskell has lots of those unit containers. The simplest one is one called identity, but there's plenty of them. And often you can get the value out of them by running some function on them. So there's definitely, I can sort of get why people often struggle with this concept of, how do I get the value out of my monad? Because there is quite a big subset of monads that are guaranteed to contain exactly one value, and often you can get at that value. But again, remember, collections are also monads, and it makes no sense to ask, how do I get the value out of my collection? Where people really start struggling is when they run into what I call semi-containers. Because these are containers that sort of look like they're guaranteed to have one value, except when they don't. And you probably run into nullable of whatever. It's one of those things where you can, you saw that example already. You can have a nullable int, and that's your ID. And maybe so this is a little bit of a different example, but maybe you say, well, if I can make sure that ID is not null, I know that I can force evaluation. I can get at the value inside of it, and then I can that's my customer ID, and now I can create a new customer object, because that requires a proper integer and not a nullable int. But since you have the return keyword here, that means that you're in some sort of method that needs to return something. What do you do in the else branch? Now, this is where people often struggle, because you have to return something, otherwise it doesn't compile. What do you do? There may not be a proper thing to return here. Well, lots of people return null, but I also see this done quite a lot of times. And you'd say, well, but couldn't we just return null here? Yeah, but a null is basically just a lazily evaluated exception, isn't it? It's just not called that. It's just called null reference exception. But it ends with that a null value is going to end with an exception sooner or later. This is really not a nice way to structure code, because if you imagine that all of this is contained in a method, and the method is statically typed to return customer, then if I see that method, I say, well, okay, so here's the method that returns me a customer. I'm just going to call it, and I'm going to play around with the customer, and that's going to compile. And then at runtime, it's going to blow up because that exception. And I didn't know. So it's sort of like, if you structure lots of code like this, it's sort of like a minefield, because you don't know until you actually try to walk inside the minefield whether it's going to blow up or not. And sometimes you step on the mine. So that's not good. This really slows us down. So we should not structure code like this, but it's hard to figure out what to do then. So what if we could make nullable of t a functor? Could we do that? Could we add an extension method that turns a t into a t result? And we can, but there's a constraint. T and t result must be structs. They must be value types, and that is because that's how the type is defined. Nullable of t is only defined when t is a struct. But within that little small subset of values in the .NET world, this actually works. You can start with a nullable int, and you can project it into a nullable bool, and that works just fine. Well, you notice that even though you start out with something that is nullable here, this is safe. There's no if-else thing going on. There's no branching. There's no exceptions being thrown. We're just doing a structure-preserving translation from one thing to another. And this is always safe. As long as you don't try to get the value out of it, no problem. Notice how much easier this is to reason about. There's no mines hidden here. Nothing will explode. And so you say, well, that's really pretty. Couldn't we do something similar with that, customer ID? Could we write something like this? That would be really nice. But, it doesn't compile, because customer is not a struct. It's not it's a reference type. It's not a value type. And then you say, well, can we make it a struct? Yeah, but you shouldn't make all your classes structs, right? We need to have a solution to this. So we say, well, wouldn't it be really? Could we ask Microsoft to lift that, constraint on nullable of t so that it would work with all things? And yeah, we could do that, but they're probably just going to say, yeah, we're not going to do that. But that doesn't mean we're lost. We can just make our own. We can make our own functor, okay? So I'm going to call it maybe. And this is not, my strange humor at place here. This is a concept from functional programming. And it's either called maybe or it's called option. Now, if you're in the OCaml or F# part of the world, it's called option of t. If you're in the Haskell or PureScript part of the world, it's called maybe of t. And I've spent a lot of time with Haskell for the last few years, so that's why I ended up writing maybe of t, even though I like F# very much. So there's plenty of ways to implement this. But one way is we can have a flag here that just says, well, is it empty or not? And then we have the item itself, if we have an item, that is. So we have two constructors. One constructor takes no arguments, just sets that flag to false. And then another constructor overload that actually sets the flag to true and remembers what it was for later use. So that's one way to do it. So now we have an object that, just like nullable of t, represents the presence or the absence of a value. Notice this is already a generically typed data container. Is it a functor? Well, in order to be a functor, we need to add a select method, and we can do that. It doesn't have to be an extension method. This is an instance method on maybe of t. And basically what we're going to do is we're going to look at the flag. If has item is true, that means item is available. It is in objects or a value of the type t, because this is an instance method on maybe of t. The selector here is a function that goes from t to t results. If it takes a t as input, it produces the t result as output. So if we call selector with the item, I get a value of the type t result. And then I can just put that into the constructor overload from maybe of t result. That takes a value. And otherwise, I can just return an empty maybe of t result. So notice that this is a structure preserving map. It takes maybe objects that has just one value and projects it into another maybe object that has just one value. And if you come with a maybe object that has nothing inside of it, it projects it into another maybe value that has nothing inside of it. So it always preserves the structure of what it means to be a maybe object. So this is a proper functor. And it turns out that it's a proper monad as well, because we can select many as well, and I'm sort of going to skip this because it's actually not that important. Plenty of examples of that around on the internet. Now, before we go back to the async example, I just want to show you how this, how nicely this composes. I told you functors compose. Let's look at a little example. So you might say, well, what if I want to pass a string into an integer? Let's have a little helper function, a little helper method that does that for us, that returns maybe a int. And you'd say, well, why do we need that? We have, potential string passing into integers stuff in the base class library already. Yeah, but it looks like this. And if you ever work with this is super awkward, because you're just writing some nice code and you think, oh, this is really pretty, and the next line is really pretty, and then you go, oh, now I have to do this. And because every time, well, one thing is the out thing. What the bloody hell is that? And then, but also you have to stop and think about, okay, so what if that is true? And it's never a problem if it's true, because that's what you want. You want the integer. But what if it's not there? This is where it normally doesn't compose, where you have to put in all those throw exceptions and blah, 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 because you don't know what to do in the absence of things. But that's what the maybe thing models, so you just return an empty one. Problem solved. And you can do the same thing if you want to pass, a date time. You can just go datetime try pass, and this is exactly the same template. And I'll show you now how those compose. So imagine that you have to develop a little car rental system. And the first thing this car rental system does is that you call collect date. So this is a little function you've written, and it goes and asks the user, oh, please input the date from which you'd like to rent the car. And the user types in some date, and that's a string. So the return value of collect date is a string. Now, you actually want a proper date. So you call try pass date with that string, that's output of this one, and it gives you a maybe of date time. Okay, that's cool. Now the next thing you do is you have another method here called collect number of days. So this one asks the user, okay, please enter the number of days you'd like to rent the car, and the user types in 10 or whatever. But again, that comes back as a string, and then you call try parse int with that string, and then you get a maybe of int. And then you probably ask the potential customer lots of other things. And once you've done with this, you'd like to compose all of that potential information into a contract that then you can then present to the customer. So we can do this with query syntax. So what we want to end up with is a maybe of contract. So I go from D and MD. Now MD is a maybe of date time, but D is a date time if it's there. And then we go further on, from I and MI. I here, even though MI is a maybe of int, this I here is a proper int. And then we can do all these things and all the other stuff we've collected, and we can call, our constructor with the date time, and we can add the numbers. We can write all the code that we normally want to write, and pass in more parameters here and so on, and we get a maybe of contract out of it. So how does that work? Well, if all of these maybes have values inside of them, then this maybe of contract will have just one value, just one contract. If just one of these things have missing data, then this one will also be empty. This will be a nothing value. So there's more sophisticated ways that you can do in order to sort of compose a lot of potentially faulty data together. But this is a pretty easy and straightforward way to get started with it. And the nice thing about all of this is all safe code. There's no need to throw exceptions or do all sorts of defensive coding. You just write nice declarative coding, and it always does the appropriate thing. No matter whether all the data is there or it's not, it always does what you'd expect it to do. So that's really nice. And then you go, yeah, that's fine. But on the contract, there's a method I want to call. How do I do that? How do I get the value? How do I get the contract out of my maybe? And okay. And then you go you write something like this, or someone writes something like this. Not you, because you're smart, but some other you. So you go, okay, let's declare a variable called Q for quote, because we need to supply a quote to the customer. And then you go, well, if it has an item, then you go item.calculate price, and then you can return. Well, you can assign that to Q. Yeah, that doesn't compile. And that very, very deliberately doesn't compile. This is by design. I always wanted to say that. This is by design. But it is. Even though those things are there, they're private fields, and they're private fields because you're not supposed to do that. The problem with things like that, again, what do you do if this is false? There's an implicit else branch sitting there, and what do you do if this is false? What would be the value of Q then? Is it going to be 0? Well, sometimes the C# compiler can catch the worst of those sorts of mistakes, but sometimes it can't. So maybe it ends up being uninitialized, and then it's 0. So that means you're now in the danger of, if you make this example a little bit more complicated, you're now in danger of showing your potential customer a price of 0. And then the customer says, oh, I was just about to rent a Ferrari for 10 days and it cost me nothing. I think I'm going to rent that. And then you go, no, I just rented out my Ferrari for 0, whatever. What's worth most? 0 euros or $0? Anyways, so by design, doesn't compile. You're not supposed to do this. Don't do that. Okay, so let's reset a little bit. So what are we supposed to do instead? Well, what if we just use this ability to have structure preserving maps? So we can just say, well, okay, so I have a maybe of contract. Let's turn it into a maybe of decimal, and I can just do that by calling, inside my select method, I can call calculate price. So this lambda expression is only going to run if there is just one contract in the maybe of contract. But it's never going to run if there's no contract there. So again, this is safe. This will never be null. No exceptions will be thrown. And you can just think, well, okay, that just behaves the way that I thought that it was supposed to behave. Very nice. Okay, so how to get the value out of my monad? Well, you don't. You inject the desired behavior into the monad. That's what we did here. we never leave the maybe monad here. We just keep on projecting from one maybe instance to another one, and then we just do the things we want to do with the things inside the monad in a safe way, and we never leave it. And that's what we're supposed to do. I don't know what you're gonna say. Yeah. But ultimately, I need to produce a result because I need to show something to the user. Fair enough. Let's go back and talk a little bit about numbers. All right, so this also happens with numbers sometimes. Yeah, I need to show something to my user, and I say, well, can't you just show them all the numbers? And sometimes that may be appropriate, but sometimes it's not. You say, no, one result. I need to produce one result and show it to the user. And then I go, okay, which result would that be? And maybe it's the sum. It could be that you just want to add things together, and then you get that number. But maybe it's some other result. Maybe you want to multiply them all together. And there's this nice convenience method called sum, but there's nothing called product. So what do? Well, there is another thing called an aggregate. So this is sort of like the general purpose produce a result from a container of data. And there's an overload that takes a seed, and always use that one because then it's safe when the input has 0 elements. But the idea with this thing here is you start with a seed, and then there's a lambda expression that basically walks you through. So the first thing it does is, let's see if we can do this. I'm getting too old here, but my knees are going to hurt tomorrow. But it starts with 1, and then it takes the -3 over here, and it says, well, 1 is going to be the x, -3 is going to be the y. We're going to multiply those two together. That's going to be a -3 because that's why I picked 1, because if I multiply something with 1, it just stays the other thing. And then it says, okay, so let's go again. Now x is -3, and then we just pick the next thing in the line here. That's 7, and then we just take -3, times 7, and then that produces a number, and then we just keep on going until we've depleted the list. So you'll also notice that sooner or later we reach that 0, and that means the output is 0. Pretty boring result there. But the idea that we have a general purpose aggregation of whatever's inside a container of data, that's pretty interesting. So we can apply that idea to maybe of t and say, let's have an aggregate. Instead of seed, I'm going to call it nothing. And the lambda is also going to be a little bit simpler because we don't need it to be quite as complicated. But then we can basically just use the ternary operator there. And we'll say, well, has item, that flag, if that's true, that means we have an item. That item is accessible. It is of the type t, because this is an instance method of maybe of t. And just is a little function that takes t as input, turns t to result as output. That's what we have to return. So we just return just of item. What if has item is false? Well, we don't have anything, but we have this seed or this fallback value of the type t result. So we're just going to return that. Yeah, okay. This turns out to be universally useful. And I'll show you an example of that. And I'm not at all done yet. So I'll just, but we'll get to part 3 now. So how do I combine dependency injection with async and await without leaky abstractions? Now, we left at the point where we said, well, it has to be async all the way. There's no other way. And I said, yeah, there is. But that other way involves the monads we just looked at and a trick. So just one weird trick. You won't believe what happens next. What I'm going to do is I'm going to move my impure operations to the boundary of the system. This is a catchphrase. If you ever heard, functional programmers walk around and say something like, make illegal states unrepresentable, that's another catchphrase. That's cool, but they should also, more walk around amongst other mortals and say, move impure operations to the boundary of the system, because that is wisdom. And basically the idea is that, at the boundary of the system, all the stuff that talks to the real world some people call it the onion architecture. But it's the same idea. At the boundary of the system is where we're actually talking to the real world. And when we talk to the real world, that's what we have, what we call impure operations or impure actions. And I'll talk about what that is. I think I'll do that with an example. So in functional programming, we distinguish between pure functions and impure actions. And a pure function is something that is something that is deterministic and has no side effects. And if you have something that violates one or both of those constraints, then it's an impure action. So we have two examples of that here. Read reservations is non-deterministic. Determinism is very strictly defined. It means that if I give the operation the same input, it should always produce the same output. And that's not the case when you're talking to a database. I could call, read reservations with the date of the 1st of November 2019, and I would get, an array of reservations back. And then I do it the next day, and I, still, the 1st of November 2019, but now I've got to get another, list of reservations back because the state of the database changed. And as programmers, we might say, well, yeah, but that's still deterministic because it's determined by the state of the database. But that's not what we mean here. The state of the database is considered to be outside the function. So this is an impure operation because it might return different answers, though the question would be the same. Another example of an impure operation is create, because this has a side effect. This is going to add a row to the database. And to make it even worse, it actually also returns a number that's a new one every time. So that's even worse. So what we want to do is we want to move those to the boundary of the system, and that means we want to move them to the post method. It's not that we want to get rid of them. We need those things to happen, but we just don't want them to happen in the core of the application. We want them to happen at as close to the boundary as possible. So we'll start with this one. That's the easiest one to move, because you'll notice there's no conditional branching before this happens. This always happens. So you might say, well, this try except method that is a domain part of the domain model. Why does it even have the responsibility of calling read reservations? You could actually argue that this might actually be breaking the single responsibility principle. So I would say, well, we could just say, let's make it a precondition for calling the method that you already have that data from wherever. So we're just going to promote it to a method argument. Problem solved. It's pretty easy. Right. Sometimes things have to get worse before they get better. Now, what gets worse now is that, in order for all the code to compile, I'm going to have to change the maitre interface because I changed the signature of the method, so it wouldn't compile unless I also changed the interface. And at this point, you are welcome to say, but Mark, isn't this a leaky abstraction? And I'll say, yes, it most certainly is. But not to worry, because this is just the first of many refactorings that I'm going to do. And once we're done with all the refactorings, all is going to be good. But right now, I almost can't look at this. Let's move on. Okay, but if we do that, now we already, in the controller, we already injected the maitre d. We could just also inject the repository. That's okay. We can inject we can use the same dependency or type of dependency in multiple places. And that means we can just call, read reservations here, and then pass the reservations to try accept, and the rest of the code remains the same. So I just moved that operation. That is literally what I did. Okay, so that wasn't too hard. Now the other one is a little bit harder, because you'll notice that there's a conditional here. We may not always reach this. Sometimes we just return null instead of actually, calling repository create. So how do we deal with that situation? Well, first of all, we need to figure out if we want to move this, we'll need to figure out how to, tell the caller what we decided. We need to decouple the decision from the side effect that it has. So how do we communicate to the caller what we've decided? Well, so far we've used this nullable int and say, well, if that's null, that means we rejected the reservation. So we could sort of use that same idea and use some sort of nullable of, whatever. But you'll have to remember that nullable of t has this constraint that t must be a struct. And what if we can't return something that is a struct? What if we need to return, for example, if I just want to echo back the reservation if I decided to accept it? That is often a fairly good way of doing it, it turns out. I couldn't do that. But I could do it, if I use maybe of t, that has no constraints. So as the first step, in my refactoring, or the next step, I'm going to just change my nullable of int to a maybe of int. So if we just pay attention to what happens up here, I'm going to change that nullable int to a maybe of int. And the only thing that really changed here is just that instead of returning null, I'm now returning a maybe that is nothing or empty. And down here, I'm just returning a maybe that returns just one integer, and that's the ID. So that's the only change. Again, I have to go and change the maitre d interface. We'll just pretend that that didn't happen. Right. So now we have maybe of int when we call try accept. Now you may recall before that I did a null check. I checked whether the nullable int was null or not, and then I actually got the value out of the monad. But now very deliberately designed my maybe so that that's not possible. But I have that aggregate method. So I can call that, and I can say, well, this aggregate method needs 2 input arguments. And one of the arguments is when the value is nothing, and I'm going to return internal server error, because this is actually a generically typed method. So, and this one is one of those actual results. So that actually works. And the other case that I also need to handle, because that's the other argument to the aggregate method, is the just case, where there's just one ID, and this is just an ID now. That's just an int. It's not a normal int. This is just an int. And that means it's safe to just pass into OK. I know that if this lambda expression runs, it's going to be there. I don't have to do any except checking or branching. Well, there is sort of branching going on beneath the surface here, but it doesn't look like there's a lot of branching going on. So that sort of moves us in the right direction. I still haven't moved the repository create method out, but I can do that now because I can say, okay, I don't have to return that int. This ID is an int. If I don't want to call create anymore, I will not have an int, so I can't return an int. But what I can do is I can take that reservation and just echo it back, either as an empty maybe or as an int where there's just one reservation. I'm going to do that. So here, the empty may be a reservation. Here, I'm just echoing back the reservation that I got. Again, have to change the item HTTP interface. And now I have a maybe a reservation. Now, you will recall from the contract that I have with my HTTP clients that I'm supposed to return an integer in the response of any 200 OK response that I return. Before I had a maybe of int. Now I don't have a maybe of int. I have a maybe a reservation. How do I get from a maybe a reservation to a maybe of int? I hear someone whispering select, which is exactly the thing, because it's a functor, right? So we can call m.select, and we have to do some async shenanigans inside of here, but it's okay. So now we have a maybe of int. Well, not quite. We actually have a maybe of a task of an int. So, yeah, but it turns out it's okay. It's okay. So first of all, if you're confused about this thing about nested functors, this is not a nested functor. This is a stack of monads. it's a different thing. Functors are only nested if it's the same functor. So a task of an int is a nested task. A maybe of an int is a nested maybe. A maybe of a task of an int is a stack of monads, but it turns out that stack is in itself a monad. That is not guaranteed to be the case, but this one is. They usually are, but they're mathematically not guaranteed to be monads themselves. Anyways, that means that the aggregate call that I'm going to do now is going to be a little awkward. We can clean this up later on. It's a little bit task from the souls and so on. But we can clean it up. But it works. It gets the job done. We still return the ID in the OK method when we need to. But we'll notice one thing when we try to compile the code. There's a compiler warning, and it says, this async method lacks await operators. Yes! That was my problem all along. Why the bloody hell does this have to be a task? It's just a business decision. And now, away with that. We don't need that. This is a synchronous operation. It's just a decision. It doesn't need to do any sort of asynchrony. and that means also the interface here is no longer a task. We still have all these other leaky things here, so we're not out of the woods yet, but at least now we got rid of all the asynchrony, and that means that await method keyword there gets to go. Okay. Apart from that, nothing else changes. I'm almost done, but a few more things I want to talk about. Now you notice the repository there is no longer being used, so we can just get rid of that as well. Okay. What we have now is pretty close to a pure function. It's not quite pure because there is one piece of mutation, state mutation going on down here. We could figure out ways. There are ways to, deal with this sort of problem. But I'm actually fairly happy with this now because it is at least deterministic. What happens inside of this method body here, what decides whether I go this way or whether I go that way is entirely determined by the input arguments here and the capacity up here. So I can completely control how this behaves by just supplying the appropriate arguments. So if we go back to the controller, I'd like to ask, why are we even having this dependency? Why are we having this polymorphic thing? If you go and look at the code, you'll notice that there is exactly one implementation of IMA2D, which is sort of like a code smell. If you have one interface and one implementation, it's not polymorphic. Polymorphic means many shapes, and there's not many shapes of it. There's only one. So why are we even having that? And then someone else would come by and say, yeah, but it's really because we need it to be an interface because otherwise we can't unit test it. Because by having it an interface, that means we can create a mock or stub of it, and then we can deterministically control it, so we can deterministically control our test cases. And then I say, yeah, okay, I don't care. I'm just going to create a new XD because this is going to be deterministic as well. You can completely control how this behaves by just making sure that these inputs are appropriate. I have lots of code examples on my blog that shows you exactly why that is. So you don't need an interface in order to make things deterministic. This is as controllable from the outside as any interface is. So once we've done that, you'll notice that the MAJD dependency there, it's gone. So if you do this consistently all over, it doesn't matter. That's why I said don't worry about this because we're going to delete it. It wasn't really a good interface to begin with. The object is still there, so the domain concept is still encapsulated in the object, but we don't need a polymorphic interface. So what else is there to do? I think we can do a little bit of cleanup. We can move this to a class field, and then we can do some other magic. I sprinkle on some magic on it, and now it's much prettier. And again, I have all this code in GitHub and all sorts of other things if you're interested. But what we notice now is I refactored it to look like this. And you notice that it says select and select many. So there's some monad running here, and it turns out to be the asynchronous monad or the task of T monad. And all the things that have to be asynchronous are still asynchronous. First of all, the entire method here is asynchronous. The read reservations method here is still asynchronous. And then we just go select, we just do projection over the asynchronous monad, and the repository create method here is still asynchronous. But the try accept method here, this is now just a synchronous operation, and we just injected it into the asynchronous monad, and it doesn't really know that it's running inside that context. It's just there making decisions. So this is the best of both worlds. How do I combine dependency injection with async and await without leaky abstractions? Well, you inject the desired behavior into the async monad, the task of T monad. We know that already because that was the answer for the other question. You inject the desired behavior into the monad. So that's what we did. So behavior injection, not dependency injection. Yeah, so you still buy my, now very much on sale. But apart from that, I have an article on the blog called Async Injection. There's one called How to Get the Value Out of Your Monad. And I think all the stuff that I've talked about here is on the blog, and links to GitHub repositories and all sorts of other things. So you can spend all the time you'd like looking at this if you thought that this wasn't enough already. With that, I'm done. I still need to figure out if someone wants these things and who deserves them if anyone wants them. So the first thing we say, does anyone want a T-shirt? More than one, okay. Does anyone want a free book? More than one, okay. So we need to come up with some sort of decision algorithm there. So maybe we should, I should shut up and maybe take questions. What do you think? Is that one way to go about it?
Okay, time for questions.
Yeah, time for questions.
Okay, 9 minutes or something like that.
Right, yes?
There was a traverse in the code.
There was a traverse in the code. Yes.
What's the meaning of?
Right, okay, so...
He was implementing that.
Yeah, so you're talking about this one?
Yeah.
Traverse. Okay, so I skipped over that because it's not really important here. But basically, what traverse is intended to do is to swap the stack of monads. So we started out with a... do I have? No, I don't. Well, okay, fair enough. Okay, so we started with a... I think we had a maybe of a task of an int. But I would actually much rather have that all of this runs in the async monad because we're sort of in that context. So traverse basically just allows me to, instead of having a maybe of a task, it just swaps them around so that it's a task of a maybe. And it's a concept I stole from Haskell where this is completely general purpose. You can swap any sort of two monads and it's called a traversal. But I just wrote an extension method here that does that. And it's in the GitHub repository, so you can see how that works. But it's also, if you already know a little bit about this, it's a really good exercise to just see if you can figure it out by yourself, because it's not a lot of code, actually. Does that answer your question? Okay, so that's a pretty good candidate for winning something. But let's see if there's other questions. Otherwise, you just win all of it. Yep, okay, so there's one more.
There's a GitHub repository.
I'm sorry?
You mentioned that there is a GitHub repository now?
There's a GitHub repository, yes. So the easiest way to find that is to go to my blog. So now I have to go back to the... So we just go to the last page here.
What I'm sure I will go. It's refreshed there.
Yeah, so if you go to the blog...
I will share it in the Meetup group.
Yeah.
The blog is shared already.
Oh yeah, I have no internet. Okay, so that's...
Hey, the blog is already shared in the Meetup group.
Yeah. But if you go to the blog and there's a menu thing and there's an archive, and then in the archive you can just search on the place and find async injection, and then you can find the link to the GitHub repository there. And otherwise, always ping me on Twitter if you have questions that I can't answer right now, and I'll be happy to dig it out for you. Or send me an email. You have my email address as well. That's fine. Yes?
In Unity terms, does all these techniques mean that you make the domain services, factories, etc. absolutely pure, and just make the controllers, interactors, or whatever handle the asynchrony? Just as a methodology or technique to protect the domain? Yeah, so you're asking me whether it means that? Yeah, if the final goal, all of this is just to protect the domain.
Yes. If possible, that's what I would like to do. And often it turns out to be possible, but not always. It really depends on lots of context. And again, I'll be happy to show you, for a very in-depth answer to that question, I'll refer you to the blog. But the short answer is that there is a rather big subset of all possible applications that tend to run in short bursts of action, if you will. So anything that is request-response based, like a website, you get an HTTP request and you have to produce an HTTP response fairly quickly. That's sort of like a type of application where execution is based on short bursts of activity, if you will. All sorts of message-based applications sort of fall into that category as well. Now, all those types of applications, it's often possible to produce something I call an impure sandwich. And the idea here is basically you collect a lot of data up front, and that's impure, one or more impure operations. And once you've collected all the data, you pass it to your pure, decision or domain business logic, and it produces a result, and then you do something impure with that result as well, sending out emails or printing things on the screen, things like that. It is surprisingly often you can get away with that style of architecture, and it doesn't require a lot of jumping through hoops if you want to do that. If you don't tell your fellow object-oriented programmers that that's what you're doing, they may actually never, discover what it is that you're doing. They just say, it's funny how this code base is so easy to, maintain, because there doesn't have to be a lot of monads involved. But you may have other scenarios, like if you have very long-running applications, like something that has a UI, runs on your phone, for example, where you have constant interaction with the physical world, that's harder. The best solution in a functional sense to that is something called a free monad that I know of, but that's not something that I would subject my fellow C# programmers to. This is more like if you're actually in the Haskell world, that makes sense. So I'm not trying to sell this as being, always do this. I'm just trying to give you some options where, if this makes sense in a particular scenario, then by all means go and use it. And if you just want to do async and await in your interfaces in other cases, then go and do that. But I'll be happy to point you to articles where I discuss this in more depth if you'd like. But I think that's what I'd like to say about that now, if that's okay with you. Okay. Sure.
A question?
Yes.
I think that I'm asking if you have any receipt or secret source or something. If you have a large code base with a dynamic language instead of a type one.
No, I don't. I'm sorry, but that is basically just that you just asked about a part of my knowledge that's not there. I only know so much, just like any other person, and I haven't done dynamic language programming in 10 years. So the last time I did something with a dynamic language was with Angular and JavaScript, and that's like 7 years ago, and I walked away, disgusted. I never looked back. So I'm sorry. I actually don't know how to answer that question. So
We try to do some gradual typing or something that approach. Do you think that?
Yeah, I think you should have another speaker here that could actually answer. I don't actually know how to respond to that. I'm sorry.
I know one. I can. That is using. I can send it to you. I know one person here in Barcelona.
Yes.
Yeah. So this type of pipe-style programming, it's nice because it's the abstraction and the code looks nicer, but also hides like a lot of implementation details from you, and we know that from enumerables and stuff, it's really nice to write them, but then when you are debugging them, and this is as parallel, for example, it's a hell.
Right.
So do you have any kind of advice, like to debug this type of things, because it seems like.
Yeah. So I actually get that question about debugging quite a lot, and. This answer is one of those answers that's a little bit hard to believe until you actually tried it. But the more you move towards having pure functions, the less debugging you need to do. Things just don't behave as odd as they do when you have lots of when you have state mutation all over. Yes, you need to debug, and I need to debug as well, because I absolutely don't understand what happens, and I need to step through very carefully to understand, that flag changed over there, that flag changed over there, and all those sorts of things. But that sort of weird behavior goes away when you start doing more functional style. So it's not so much the pipeline style. So I can definitely imagine, so if you take this pipeline style and you still try to combine it or compose it with lots of things that mutate states, it's probably going to get quite difficult. Yeah. But if you sort of take it in the functional direction overall, my experience with it is that I don't debug things very often. I've been writing Haskell code for the last 3 or 4 years, not full time, but just a lot actually. And if there is a debugger for Haskell, I've never figured out how to use it. But because usually when I run into Haskell, I just start playing around with the small functions that my bigger functions are made up of, and then I figure out what the problem is. It's not that hard. Not that everything not all problems will magically go away, but that's sort of the overall idea.
In case of C#, since you are mixing it with the mutable, like
you can still set breakpoints, but I agree that it's a little bit more awkward than just stepping through, because you sort of need to tactically deploy your breakpoints first and then go into the debugger. Yeah. That's what I do when I in sort of that mixed scenario. I hope that's not a totally asshat answer, but that's my experience.
Okay, last one, please. Okay, two more. Yeah.
Okay. So two more. Okay, so and that gentleman afterwards. Yes.
My question is with regards to this thing you said that you want to push the side effects to the boundaries.
Yeah.
So I'm thinking about in this clean architecture or hexagonal architecture styles, usually you have different layers like the presentation, use cases, for example, repositories, and the use cases usually are the ones that have the business logic, right? Usually presentations, they delegate to the use cases, and the use cases actually decide.
Yeah.
In this proposal of moving things to the boundary, doesn't it make it so that the handler or basically the entry point has all this logic, so that it mixes the accesses to the repository, doing actually some pure domain functionality and get away?
Yeah. So the thing that so this sort of ties into the other question from before, where the first thing I need to say here is that you can get away with this, collect all the impure stuff up front, pass it into a pure function, get the things back and do some more impure with it. This is what I call an impure, pure, impure sandwich. You can get away with that quite a lot, but not always. But it's true that what happens is that at the entry point, so you saw that in the final controller here, is that you'd say, well, okay, so it looks like a controller ends up having the responsibility of actually calling into the repository here and here. So that's sort of what you had in mind with your question, as far as I understand you.
Yeah.
And then again, if this, what happens here is actually a piece of translation into user interface. Because, well, this is a REST API, but this could also be something that actually ends up being, some HTML displayed on a page. That's true, but basically, if people are wondering about what I'm talking about when I'm talking about an impure, pure, impure sandwich, it's sort of like, because it looks like a sandwich, you have the top layer of the sandwich, something impure happens. Then you have the pure stuff, which is actually try accept, and then you have some more impure stuff happening at the bottom. So you sort of have the good parts are protected by all the dirty parts, if you will. So it's actually sort of like a reverse sandwich, because that's not the purpose of a sandwich. But anyway, so yeah, the funny thing about these things, if you look at it, this is 4 lines of code, and it looks like 75% of it looks like it's impure. So you only have one pure line of code, and that's that. But what often happens, or what could happen in problem domains that have interesting business logic, is that even though you only have one function call, all the interesting stuff actually happens in here, because this actually hides a lot of complex decision-making behavior in between. But it's true that we sort of have to think about the composition of applications a little bit differently, because what we often used to, when we were thinking about, you said, if there's a user interface and if there's some, data access layer and so on. And we often see those application architectures that are layered, where, you have the user interface at the top, and then you have a controller layer, and maybe you have a domain layer, and then you have the data access layer in the bottom, and sort of the call goes all the way through. And what sort of happens with this, ports and adapters hexagonal architecture instead is that it's we don't really draw it as these layers anymore. We draw these things as concentric circles, and that means instead of having the data access layer in the bottom and the user interface at the top, it's all at the boundary. So that's why we sort of just instead of we're sort of wrapping the layers around and saying, well, all the stuff that actually talks to the real world is all at the boundary, and in the center of the things are the actual business decision logic, and the flow is a little bit different. But it's first and foremost, I think it requires a slight shift of the way we think about how composition turns out to work. But my problem with the layered architecture, and I'll keep it short now, my problem with the layered architecture is that it looks good on paper, but it rarely works very well in practice. People often struggle with that sort of architecture, unless they sort of make this sort of maneuver. I think that's probably as much. But I owe this gentleman an answer as well. And
last question.
I mean, I have plenty of time, but
we will have more time afterward for the networking. Yeah, but last question, and we'll go. Yeah.
Yeah, maybe it's a stupid question, but you said that we cannot use reference types in select statements.
We can't use which types? I'm sorry.
Classes. Reference.
That was specifically for nullable of T.
Mm-hmm.
But we can use it in select.
All the other select implementations or structure preserving maps that I showed here, reference types are absolutely possible. That's what we did with maybe. But the constraint is specifically for nullable of T, and that's because nullable of T in itself has that constraint. That constraint just follows us, all the way through. Does that help?
Yeah. Sure.
All right. So are we?
Okay. Thank you very much.
Bye.
Yeah.
Since I couldn't answer your question, you get the book.
I've already had it, so
okay. So I think I also only could sort of half answer your question. So if you don't have the book, so who gets this one? I think you get it. Sure.
Okay, guys, please take everything from the room because it will be closed. So you go to the kitchen, take everything there. And I have 4